and with geomagnetic conditions holding its hand as they climb down the ladder. The only space weather note yesterday was a solid little sun-diving comet. It's burned up and gone at this point, as the Kreutz comet family are mostly having their final orbits here and vaporizing. Up first in the articles, folks, if it seems like this is the opposite story you've heard about the United States under climate change projections, you are right. There are now numerous climate aspects that show inconsistent forcing to a number of items. This is largely due to what we saw from this journal earlier this year. They are oversensitive to carbon, uncertain about cloud forcing and aerosols, and these create bias and propagate errors. But it's not as bad as this. Probably the paper in this journal of the least merit in all of 2020. They go back to the Maunder minimum period and find irradiance values did not change as much from then to now as they had imagined. They say this lower change in irradiance means the sun has had less of a role to play in climate change. I'll give a pass to the Chinese and German grant grabbers co-authoring this paper, but Dr. Rempel is from Boulder, University of Colorado, just an hour up the road from me, and it will take everything I have not to drive up there during his office hours tomorrow and tear him a new one. Boulder is where the global electric circuit science was born, with his colleagues. They are crushing it on cosmic rays and other aspects of particle forcing. And to see, in 2020, 3 years after the release of the particle forcing dataset for CMIP6 for the specific purpose of climate studies, we see one of the top journals ignore 75% of the solar input to this planet. Didn't even bother trying. And they allowed a pandering conclusion into the mix with it. The saddest part of all is that this is an AGU journal, and the AGU has been leading the charge on solar particle forcing in the Western world. Very disappointing from geophysical research letters here. Let's review the ocean science we've got just this year. Gulf Stream and critical currents are slowing. AMOC is slowing. These are being triggered by a slower version of the day after tomorrow where ice melt hits critical desalinization points. We've seen the salinity and stratification patterns changing as well, and last week, the bombshell dropped that these processes led to the mini ice age, and that polar ice loss in general can throw our planet into cold. And today, let's find that one on steroids. Folks, the last extinction level cold event was the Younger Dryas, and indeed, it came on vastly more rapidly and harshly than they realized. As if a geologically instant ice age isn't scary enough, they identify the same ice melt and AMOC changes preceding that event. Folks, this is an absolute fact. When we're lucky to have the ice at the poles, the lower latitudes will be temperate. When we unlock the ice from the poles, it will trigger an ice age. End of story. Actually, not end of story, because there's probably something even scarier involved in those long-term cyclical disasters, and that's a solar micronova. We have seen that the stars towards the galactic center have been activating in a line towards the sun, implying the current sheet radial outward effect, and today we confirm that AD Leonis is activating. AD Leonis is not towards the center of the galaxy or away. It's pretty much right in line in terms of distance away from the center, but it's situated way up in the northern part of the sky from Earth's perspective. At only 16 light years away, it's a great hold-the-line candidate as it stands equal distance as the sun does from the galactic core, but as a smaller, more easily activated M-star, the sun will take a bit more time and likely the full galactic field reversal moment to activate.